El Nino. To understand the phenomena of El Nino, we have to understand the Walker cell or Pacific Ocean cell. Walker cell plays an important role in global weather. It is entirely Pacific Ocean based cell and arises on account of marked difference in the surface temperature of Eastern and Western Pacific, that is, adjoining the coast of South America and Australia respectively. Three conditions may arise in Pacific Ocean cell, that is, La Nada, La Nina and El Nino. La Nada. It is the phase of normal conditions. The term La Nada or neutral conditions describes the phase when there is neither an El Nino nor La Nina. Let us observe the Pacific Ocean cell during La Nada conditions. Ocean water adjoining South America, that is Eastern Pacific, is cold due to presence of Humboldt current, whereas ocean water adjoining Australia, that is Western Pacific, is comparatively warm. Consequently, there is high pressure belt in Eastern Pacific and low pressure belt in Western Pacific. As a result, surface winds blow from Eastern Pacific to Western Pacific. These winds get warm and rise upwards. After reaching the upper atmosphere, these winds start moving towards Eastern Pacific. By the time these winds reach over Eastern Pacific, these winds are cold enough to descend downwards. Implications of La Nada conditions. Surface winds drag the ocean waters towards the Western Pacific. Consequently, the level of ocean water is slightly higher, nearly 60 cm in Western Pacific as compared to their level in Eastern Pacific. The drag experienced from the surface winds results in equatorial ocean current. The warm rising winds experience condensation over the Western Pacific, resulting in heavy rainfall on the coast of Asia and Australia. The continuous shift of ocean water towards Western Pacific facilitates upwelling currents in Eastern Pacific. Upwelling refers to the rise of ocean water from lower levels onto ocean surface levels. Upwelling facilitates movements of nutrients in lower layers to surface of oceans. Availability of nutrients at surface of oceans facilitates large biodiversity. Consequently, coast of Peru is one of the largest fishing grounds of the world. La Nina. La Nina refers to the conditions when the Humboldt current is unusually cold than normal conditions. In other words, water adjoining the coast of South America, that is Eastern Pacific, are unusually colder. Consequently, there is high pressure belt in Eastern Pacific and low pressure belt in Western Pacific. The pressure difference between Eastern and Western Pacific increases. As a result, surface winds blow faster than even La Nada conditions from Eastern Pacific to Western Pacific. Implications of La Nina conditions. Fast surface winds drag the ocean waters towards the Western Pacific. Consequently, the level of ocean water is even higher in Western Pacific than their usual level during La Nada conditions. The drag experienced from the surface winds result in faster movement of equatorial ocean current. The warm rising winds experience condensation over the Western Pacific, resulting in even heavier rainfall on the coast of Asia and Australia. La Nina conditions are responsible for floods in Australia and Indonesia. The larger shift of ocean water toward Western Pacific facilitates strong upwelling currents in Eastern Pacific. As a result, there is oversupply of nutrients at the surface of oceans, leading to abundance of fishing. La Nina has positive impact over Indian monsoon. The trade winds are strong during La Nina. As a result, India receives surplus rainfall during La Nina conditions. El Nino. El Nino is a temporary replacement of the cold Humboldt current by a warm current along the coast of Peru in South America. Sometimes these warm currents become so intense that the surface water temperature of the ocean rises by 10 degrees Celsius. The presence of warm water in Eastern Pacific results in low pressure adjoining the coast of South America. As a result, the Walker cell is altered and wind starts blowing from Australian side towards the South American side. Implications of El Nino. The warming of tropical Pacific water affects the global pattern of pressure and wind systems, including the Indian monsoon. During El Nino, Indian monsoon weakens. It is believed that the severest drought in India are caused by El Nino. The warm rising winds adjoining the coast of South America bring rainfall and even floods. As winds move from Australia towards South America, Australia experiences drought. Forest fire become common occurrences. The upwelling currents reduce in Eastern Pacific. Consequently, the nutrient level in upper layers of Eastern Pacific falls drastically, leading to loss of biodiversity and reduction of fishing. The equatorial ocean current is replaced by equatorial countercurrent. Equatorial countercurrent moves from the coast of Asia and Australia towards South America.
For best learning, you can watch this video along with PrepMates Engage UPSC series, which is available online as well as offline. Book features: complete subject in a single book with practice and past year questions at the end of chapters. Model answers for UPSC mains from authors. Using the application PrepMate and web portal prepmate.in, you can access comprehensive digital support in form of videos, mock prelims, answer writing practice and regular updates.